I mean, if you were hired to, like, swap out a bank's entire security system, right? The cameras, the lasers, the vault timers,
Oh,
and you
man.
had to do it overnight
Yeah.
while the bank is still, completely full of money.
Right, without tripping a single alarm.
Exactly. You would demand a flawless blueprint. You wouldn't just walk in with wire cutters and start guessing, like, which wire does what.
Yeah, because, I mean, a single crossed wire means the doors lock, the alarms blare, and the entire financial operation just grinds to a halt. The margin for error is absolute zero.
Well, in the IT world, this exact scenario plays out every single day. We are talking about migrating really complex network configurations between competing firewall vendors.
Yeah, specifically taking a massive active network running on a sonicwall firewall and moving it entirely over to a watchguard system.
Right, and you have to do it without breaking the internet for the business relying on it.
Right.
So for today's deep dive, we're getting into a massive stack of sources from a project called the sonicwall to watchguard migration toolkit.
Built by the n2nhu lab.
Exactly. And we have detailed design documents, operations manuals, architecture notes, and schema configurations.
That's a lot of material.
It is a ton. But the mission today isn't just to learn about firewalls. We are exploring this really fascinating blueprint for how we can, like, integrate AI and automation into these high-stakes workflows.
Without losing human accountability, which is huge.
Yeah, because everyone is desperate for the speed of AI right now. But nobody wants to deal with the catastrophic failures that happen when an AI, hallucinates a critical business policy.
Oh, absolutely not. And this toolkit offers a very real solution to that tension.
Okay, so let's unpack this. The core problem this toolkit tackles is something the documentation calls the GIM baseline.
Yeah, the GIM baseline. It refers to this hard ceiling of a one engineer operation.
Right.
So a single senior field engineer, the metaphorical GIM, working manually, can convert roughly one customer firewall configuration per day.
Just one.
Just one. Jim has to sit there, read the sonicwall configuration line by line, mentally translate the logic, and then carefully rewrite it into the watchguard format.
And that mental translation is the real bottleneck. Because when an engineer spends 2 hours deciphering some hyper-complex firewall rule and they finally type out the translation.
Their reasoning dies with the keystroke.
Exactly. The knowledge lives entirely in Jim's head. So if Jim goes on vacation, or if you bring in a second engineer, that second person ends up spending another 2 hours researching the exact same obscure routing rule.
The knowledge doesn't compound. Adding more engineers to a manual process like this doesn't actually multiply your throughput. It just multiplies your payroll.
Which is terrible for a business. The firm is basically capped at a linear progression.
Right. One migration per engineer per day.
So the toolkit completely flips this paradigm. And it starts by aggressively filtering out the noise.
Yeah, the source documents point out that in a typical firewall configuration file, roughly 95% of the data is completely irrelevant to the custom business logic.
95%. That is wild.
It really is. It's mostly vendor built-ins or just dead disabled rules. I mean, think about standard web traffic. Port 80 for basic HTTP or port 443 for secure HTTPS.
Right. Those function exactly the same way whether you're on a sonicwall, a watchguard, or literally your home router.
Exactly. So having a senior engineer waste brain power manually migrating those standardized definitions is a massive waste of resources.
So the toolkit's parser identifies those standard built-ins and just passes them through automatically.
Leaving the human expert free to focus purely on the 5% that actually matters, the custom bespoke rules.
But the way the toolkit handles translating that remaining 5% is what really caught my eye. Because instead of building a direct, sonicwall to watchguard dictionary, the developers engineered an algebraic concept map.
Yeah, they use this underlying principle defined as object multiplied by verb equals action.
Okay, break that down for me.
So instead of mapping a specific term from vendor A directly to vendor B, they map everything to an abstract vendor-neutral concept layer.
Which, I gotta be honest, on the surface feels like a totally unnecessary middle step.
How so?
Well, I mean, if I want to translate a book from French to Spanish, I am not going to translate the French into ancient Latin first and then translate the Latin into Spanish. I just buy a French to Spanish dictionary.
Right, I see what you mean. And in a two-vendor ecosystem, a direct dictionary works totally fine. But enterprise IT never stays in a two-vendor ecosystem forever.
Oh, that's true.
Eventually, you'll need to migrate configurations involving Cisco, Fortinet, or Palo Alto firewalls.
Right.
If you rely on direct translation dictionaries, adding a third vendor means building a Cisco to sonicwall dictionary, a Cisco to watchguard dictionary, and so on.
Oh, wow. Yeah, that becomes exponentially unmanageable really fast.
Exactly. So the algebraic layer future-proofs the entire architecture. By forcing everything to translate into those neutral underlying concepts.
Like things that developers tag as a VPN site-to-site or concrete address.
Right. Adding a new vendor just means mapping that one new vendor to the neutral Latin core.
So it creates this massively scalable hub-and-spoke model.
It does. And beyond future-proofing, this intermediate conceptual layer protects the engineers from one of the most dangerous traps in IT migrations.
Which the sources call vocabulary swap.
Yeah, vocabulary swap is terrifying.
The documentation highlights an incredible example of this. These firewall vendors built their operating systems in complete isolation over decades, right?
Right.
So you get this severe semantic drift. Like in WatchGuard's ecosystem, an alias is a collection of addresses. But SonicWall calls a collection an address group.
Which is confusing, but, easily mapped.
But wait, WatchGuard actually does use the term address group too, except they use it to mean a single concrete IP address.
Oh, man.
And SonicWall calls a concrete IP an address object.
See, a direct mindless translation script would see SonicWall's address group, look up the matching word in the WatchGuard dictionary, and map it directly to WatchGuard's address group.
Meaning you would instantly translate a massive collection of network addresses into a single IP address.
The network traffic would just hit a brick wall. The whole business goes dark.
And the algebraic concept map prevents this, because it forces the system to understand the underlying concept of, like, collection of addresses before it ever attempts to write the new vendor's rule.
Precisely. So the parser handles the noise, and the concept map handles the known vocabulary.
But, as any senior engineer knows, you eventually hit a completely novel, custom firewall rule that the system has literally never seen before.
And this brings us to the absolute bedrock rule of the entire toolkit. It's a foundational directive the n2nhu lab built into the core engine.
No claim without provenance.
Exactly. No claim without provenance. The engine is strictly forbidden from guessing.
It cannot fabricate a translation, it cannot assume intent, and it cannot just blindly pattern match and hope for the best.
To enforce this, the architecture creates a really rigid divide between what the machine is allowed to do and what the human operator is allowed to do.
Right. The machine is restricted entirely to structural observations.
Which means the machine can count things, it can measure shapes, and it can identify data types. It can tell you how many lines of code exist or what type of brackets are used.
Well, the human operator is the only entity allowed to make semantic claims.
Right, meaning declaring what the rule actually does for the business logic. The math is delegated to the machine, but the meaning is reserved for the human.
And the toolkit actually uses a dedicated schema learner to analyze these novel rules.
It takes the new code block and builds a mathematical fingerprint called a 7-slot feature vector.
Yeah, it analyzes the children tags, the naming tokens, and the value patterns. Like, it identifies if the rule contains a UEO-ID, which is basically a unique digital fingerprint.
Or if it contains standard internet routing numbers like IPv4 or IPv6 addresses.
It even looks at its structural neighborhood, right?
Right.
Like the context clues of the surrounding code blocks.
Yes, the machine takes all of that structural math and calculates a similarity score comparing the novel rule to rules it already has stored in its database.
But here is the kicker. The 7th slot in that feature vector, the slot reserved for the actual business function of the rule, is intentionally left blank.
The machine never fills that in.
Only the human operator can declare what the rule does, and they have to provide a verified citation to prove it.
And I know what you're thinking. Looking at this workflow, there is a massive temptation here.
Oh, for sure. Like, let's say the machine analyzes a brand new rule.
Yeah.
The math comes back saying it has a 95% structural match to an existing VPN policy we already know.
Right.
Why not just let the system auto-translate it to save time?
Because equating structural identity with semantic identity is a recipe for disaster.
How so?
Well, you can have two firewall rules that are structurally identical in every mathematical way. They both open a specific port, and they both route a specific IP address.
Okay.
But one of those rules is routing public guest Wi-Fi traffic to the internet, and the other one is routing the CEO's laptop directly to the highly classified payroll server.
Oh, wow. Structurally identical but semantically opposite.
Exactly. Auto-translating based purely on structural similarity means You might accidentally grant the public Wi-Fi access to the payroll server.
Which is a nightmare.
The machine is allowed to flag the similarity and say, hey, this looks 95% similar to a VPN rule, but it hard stops there.
The operator has to look at the rule, verify the business context, and provide a required citation before the toolkit accepts it.
No claim without provenance.
But wait, if the human still has to manually research and make the final call on every single new rule, how does this actually save any time? We're right back to Jim reading manuals and typing things out.
Well, this is exactly where large language models, AI chatbots, are integrated into the workflow.
Ah, okay.
But they are kept on an incredibly tight, strictly scoped leash.
Yeah, the source documents outline a deeply restricted role for the AI. The LLM is only utilized to draft candidate answers and fetch web citations for the human to review.
It cannot auto-merge anything into the codebase, and it cannot override past human decisions.
The most fascinating restriction is how the system handles the AI's confidence scoring.
Oh, yeah.
The toolkit will never mark an AI draft as high confidence unless the AI provides a verified non-404 URL citation that actually contains the relevant technical terms.
It doesn't just take the AI's word for it. The toolkit physically fetches the web page the AI suggests, reads the text on the page, and verifies the AI didn't just hallucinate a broken link to make itself look smart.
That is brilliant. So the human operator is presented with the novel firewall rule, and alongside it, an AI-drafted translation, complete with verified web links.
And then the operator evaluates the draft through a process called the four-state triage.
Right. They have four choices. They can mark the draft, meaning the AI nail it, and the translation goes into the approved corpus.
Or they can mark it edit, meaning they manually tweak the AI's draft and their edited version goes into the approved corpus.
The third option is harmful. This happens when the AI drafts a fundamentally bad rule or hallucinates something dangerous.
Right. The operator clicks harmful, and that specific pattern is banned.
And this generates what the developers call the banned corpus, which basically acts like an institutional immune system.
I love that concept.
Because most AI workflows today just throw negative data away. You get a bad output, you regenerate the prompt, and you move on.
Yeah, and if you're listening to this and you've ever had to fight with an AI generating the exact same broken paragraph week after week, you know how maddening that is.
Oh, totally. But the n2nhu lab recognized that inefficiency. They save the negative signals.
So if the AI generates a new draft tomorrow that structurally matches a previously banned pattern, the mathematical engine instantly suppresses it before a human even sees it.
The engineers never have to fight the same AI hallucination twice. The system literally builds antibodies.
It really does. But surely not every novel rule is an easy approve or ban.
Right. What happens when an engineer looks at an AI draft, looks at the code, and just draws a complete blank because it's too obscure?
Well, that leads directly to the fourth option in the triage, the sideline.
The sideline?
Yeah. When a rule is too complex or too risky to approve on the spot, the operator pushes it to the sideline queue.
And this is how the system manages to scale from Jim working alone to a highly coordinated team of engineers.
Because sidelined items are pushed into a centralized queue and managed through strict service level agreements, or SLAs.
And those based entirely on how frequently they appear across the customer base, right?
Exactly. The prioritization mechanism is incredibly efficient. If a sidelined rule is Tier 1, meaning it has only been seen once or twice across all active migrations, it can sit indefinitely.
Right, it's a rare anomaly, not worth stopping production for.
But if a rule hits Tier 2, meaning it's been seen between 3 and 9 times, a senior engineer is required to perform deep research on it within 30 days.
And if it hits Tier 3, which means it's been seen 10 or more times, or impacting a high-revenue client, the SLA requires a 7-day turnaround.
And the deep research required to clear those higher tiers is rigorous.
Yeah, it mandates at least 2 independent vendor citations, peer review by another senior engineer, and a mandatory process they call lab verification.
The lab verification isn't just reading code on a screen.
No. The engineers literally take the translated rule, rack a physical watchguard firebox appliance in a lab environment, load the configuration, push data packets through it, and physically measure the round trip.
just to guarantee the network traffic routes exactly the way the business logic dictates.
And every single piece of deep research feeds directly back into the approved corpus.
This is exactly how a basic translation tool transforms into a compounding team knowledge system.
Like the first month a team uses this toolkit, the migrations might actually feel incredibly slow.
Because they're constantly hitting novel rules, sidelining things, waiting on lab verifications, and banning AI hallucinations.
But by month 3, the shared corpus has seen almost everything. The institutional antibodies are fully built, and the approved translations are locked in.
A massive enterprise migration that used to take a senior engineer an entire day drops to just 1 hour.
The collective expertise of the entire team compounds with every single migration they perform.
It's amazing.
So the 4-state triage is clear, the sideline shoe is cleared, and the toolkit finally spits out the shiny new WatchGuard XML configuration file.
But the file isn't ready to send to the customer yet.
No, it still has to survive the validator.
Right. And the project's captain, Jimpames, has a quote featured prominently in the architecture notes. He says, "Every $1 we spend on diff is maybe $100 we don't spend on debug."
The $1, $100 principle.
Yeah, so the concept of diff refers to running a local text comparison, finding the differences in the code locally on your laptop.
While debug means hunting down errors on a live machine.
And it is infinitely cheaper to build a local validation tool to catch a tiny syntax error in the XML code in milliseconds than it is to upload a broken configuration file to a live firewall in a production environment.
Because if you upload a broken file to a live firebox, you trigger a 60-second hardware reboot, crash the network, and the machine spits out a cryptic error log that takes a senior engineer 3 hours to decipher.
It's a nightmare. So to prevent that $100 debugging nightmare, they built a bidirectional comparator that rigorously checks the emitted WatchGuard file against the absolute ground truth schema provided by the vendor.
And the specific bugs this validator catches are just wild. They really expose how bloated vendor software can get.
Oh, for sure.
Like the sources call one of them the sonicwall cruft. By default, sonicwall automatically generates 15 IPv6 alias entries per interface. Things like XC IPv6 primary static address.
Even though IPv6 is the newer standard for internet routing numbers, many businesses still operate entirely on the older IPv4 standard.
Right.
But SonicWall's operating system just assumes a default deployment and generates those IPv6 entries anyway, even if they are completely unused.
Just generating pure noise.
Right.
And WatchGuard's operating system doesn't auto-generate or utilize those specific aliases.
So when the translated file hit the validator, it caught 47 dangling references.
The WatchGuard file was suddenly looking for 47 addresses that simply didn't exist in its ecosystem.
If you tried to load that on a physical WatchGuard, it would error out immediately.
So the team had to build a specific skip pattern into the tool to automatically filter out that vendor cruft during the final export phase.
But my favorite bugs the validator caught were the capitalization errors.
Oh, yes. Because they perfectly illustrate why human engineers shouldn't be wasting their brains on syntax.
Exactly. So SonicWall exports its any rule, as in allow traffic from any IP address with a lowercase a.
Okay.
But WatchGuard's operating system strictly requires the built-in rule to be spelled any with a capital A.
It's just nuts.
It traces back to how these underlying operating systems were built decades ago. Some legacy systems are case-insensitive, while POCX-compliant systems strictly differentiate between uppercase and lowercase letters.
And SonicWall also uses a schedule rule called always on, all lowercase, tied together with a hyphen.
While WatchGuard requires always on, capitalized, separated by a space.
To a human, always on and always on mean the exact same thing.
But to a compiler, they are two entirely different commands.
If an engineer typing manually misses that lowercase a or includes that hyphen, the WatchGuard firewall physically rejects the entire configuration file.
The entire migration bricks. The customer's network stays down.
The validator is vital because it catches the lowercase a before it costs the team $100 in debugging time.
It perfectly encapsulates the philosophy of the entire toolkit, you know. It allows the machine to handle the pedantic structural math flawlessly, freeing up the human experts to manage the high-level business logic.
Totally. I mean, we started by looking at a toolkit designed to solve a very specific IT bottleneck, migrating firewalls.
Right.
But looking at the broader architecture, n2nhu Lab built something much larger. They built a localized learning system.
By strictly separating the mathematical structure from the semantic meaning, the system remains anchored to reality.
They successfully leashed the AI.
They did.
They require human citations. They fetch live URLs to eliminate hallucinations. and they built an institutional memory through the approved, banned, and sidelined tiers.
They solved a massive scaling problem without ever sacrificing human accountability.
And I think the core takeaway here is that automation is most powerful when it amplifies human expertise, rather than trying to wholesale replace human judgment.
It is about building a foolproof blueprint for that bank security system swap, ensuring the expert is making the final call on every wire, rather than handing a robot some cutters and crossing your fingers.
Exactly. And looking at the sheer rigor of this process leaves us with a pretty provocative thought.
Yeah, if enterprise network engineers demand this intense level of structural rigor just to migrate a firewall.
If they enforce no claim without provenance, if they build entire banned corpuses to actively suppress AI hallucinations, and if they mandate verified, non-404 citations before allowing an AI to tweak a single line of code.
Why don't we demand that same level of strict structural provenance from the AI tools we casually use to read our emails, research our health, or run our businesses every single day?
It completely reframes how you look at the chat box on your screen, doesn't it?
It certainly does.
The next time an AI hands you an answer, take a page from the migration toolkit and ask yourself, where is the provenance?